this second one that we have comes up with something where you end up with P cos theta equals something and P sine theta equals something. And the thing that's confusing about that is that you've got both of the unknowns kind of together. So you combine them by doing this one divided by this one. You do this divided by this. You get P sine theta divided by P cos theta, which is whatever these two values here are divided. And so you end up with the p's cancel and you end up with tan theta equals something. And then you can find out what theta is, etc., etc. Yeah, 74.4. And the answers are on the next page. However, the main thing I'm interested in at this stage is, have you resolved the forces correctly and then drawn the new diagram that goes with it? Okay, that's the most important thing that we're looking at this stage. And unfortunately, question B and I think question F both have this idea of having to divide by the two things that you've got there, okay? I will ask you to have a look at these ones later on as well, but just one thing to think about here, this angle that it tells you is 120. So what did people do? So the little one is 60.
No, the thing 90.
Oh, you could do, yeah, you could do that one is 30 and then do that and that. It's going to give you the same values because of the fact that sine of 30 and cos of 60 are the same thing, the co-function that we've said before. So you have got the answers for these down here. I'll make the answers a bit bigger so that when I give that to you in the PDF, you can have a look at them. The things I most want to see, though, is that the diagrams, we're just building up the skills for the diagrams. We will be coming across this time and time and time again. So there's absolutely, I'm not expecting you to be perfect on the solving equations part of it. We are going to try and use these skills now in more kind of mechanics-y kinds of situations. It would be very, very odd if they gave you something like this in the exam. I say very odd because they've just never done it before and they would never do it again. What they would always do is they would give you a description of some kind of scenario and then they would ask you about that scenario, okay? So let's read this scenario that we've got here. It says, a smooth bead Y, and we're going to talk about a smooth bead down here in a second, is threaded on a light, inextensible string, like a bead on a necklace, okay? The ends of the string are attached to two fixed points, X and Y. This should say X and Z. I've just noticed that it's X and Z. It should say X and Z, not X and Y. On the same horizontal level, the bead is held in equilibrium by a horizontal force of magnitude 8 newtons acting parallel to ZX. There's ZX, there's the 8 newtons that's pulling it. The bead Y is vertically below X and angle XZY is 30. XZY is 30. Find the tension in the string and the weight of the bead. So we've got a diagram that they've given us some starting points of things here, but we haven't quite got all of the forces included on this. Before we label any of the forces, I want to read what we've got down here in the blue box. As the bead is smooth, the two parts of the string can be considered as a single piece of string, and therefore the tension is the same throughout. Okay? It's like when you had the pulley questions, because the pulley is smooth, the tension is the same on both sides of the pulley. It's the same thing here, that this tension will be the same as this tension in the string. Why have I got the tension going away from the string, from the bead, sorry? It's acting opposite direction to that weight and the pulling force. And also, I try and get you to do this a lot during mechanics. If you imagine that you were the bead, which feels quite strange, you have to imagine that you are a bead thread on a piece of string, it would feel like the string was pulling you upwards and the string was pulling you diagonally. When I draw a force diagram, I am drawing the forces from the point of view of the bead. So you're going to get very good at imagining yourselves as static objects and beads and things. Yeah, Ronak.
You know, we do the tension going away from the bead. Is it that equal and opposite force? I guess Newton's third law. Is that right?
It's going to be it's going to be equal and opposite forces because of the force diagram that we'll have. Yeah, so it's got that kind of idea to it too. There's another force though that I haven't labelled on this diagram, which I should do. Weight. I could do mg, but actually I'm just going to do W, because I just want to find out what the weight is. I don't want to find out what the mass is, I want to find out what the weight is. So we're just going to draw some forces onto the diagram, and then we're going to do our proper force diagram, and then we're going to answer the question. So this one is great because it's already going left and right. This one is great because it's going up and down. This one is great because it's going up and down. This one here needs some resolving, which means splitting it up into those two pieces. So I'm going to split it into this piece and this piece up here. But look, I haven't labelled the arrows. I told you to label the arrows. What should this one along here be? To the right or to the left? Right. To the right, and this one? Up. Okay. So if I label these forces, I don't know what this angle is. It's 30. Why? Because alternate angles are equal. So running along the bottom, Masuma, is?
T cos 30.
Good. Why is it t cos 30 and not sine 30?
Because it's adjacent.
Good. So then this one must be t sine 30. Now I know you might think, oh, I don't need another diagram for this one, but I want to do another diagram for this one, and I'm going to do it with my box. To the right, t cos 30. To the left, 8. Down, W, up, and good. There's two of those bits going up. There's t and there's t sine 30 like this. That's all the hard work done, okay? All we now need to say is if I resolve, which direction do you want me to resolve first? Left, right. Why left, right? One variable. So t cos 30 is equal to 8. So t is 8 divided by cos 30, which is 16 root 3 over 3, 9.24 newtons to 3 significant figures. I'm going to pause there and give you a chance to write this down, okay?
Excuse me. Yes, sir.
They are the same. The t's are the same because of this bit in the box here. Read that again, okay? Okay, we've done the left and right. You know what's coming up. If you've already written down, you can start writing the next bit. We're not going to do diagonals. We're going to resolve our up and down forces. So the weight is equal to t plus t sine 30. Substitute this in here, whichever way you want to do it. So 9.24 blah 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 plus 9.24 sine 30. You should put in exact values if you can, but 8.3? 8 root 3, which gives you 8 root 3. 13.9 newtons to 3 significant figures. If you're still writing it down, please just keep writing it down. And in a moment, I just want to give you a couple of things about how these work in the exam and what you need to be doing in the exam, okay? If you're still writing, keep writing. In the exam, this and this are the most important things in the whole question. If you rush and get those red sections wrong, you basically get the whole thing wrong. You get none of the method marks, you get the rest of it wrong, and it's a waste of your time, okay? You must spend the time making those two red sentences, I call them sentences, making those perfect, because that's where all of the method marks are contained. This would probably be worth 2 or 3 marks. This would probably be worth 2 marks, okay, if it's done correctly. So this diagram better be perfect, because if this isn't perfect, these aren't going to be perfect, and the whole thing's a waste of your time. So do not miss this diagram out. Do not rush any of these things. Mechanics is is often a lot of marks for very little maths, because it's all stored in these two most important sentences you get to begin with. Please don't just rush everything. Take your time and tell the examiner exactly what you know. Okay? We'll look at two more. Might go a little bit quicker on this next one. So this time we've got an exam style question, and we've got something that's a bit different because of what I've got in that orange box. It says a particle of weight 8 newtons is attached at C, here, to the ends of two light inextensible strings AC and BC. Basically, there's a particle here and it's attached to two strings. The other ends, A and B, are attached to a fixed horizontal ceiling. So we're looking at this side on. The particle hangs at rest in equilibrium with the strings in a vertical plane. All it's still saying is it looks just like the diagram. They're not saying anything new here. The string AC is inclined at 35 degrees to the horizontal, and the string BC is inclined at 25 degrees to the horizontal, as shown in figure 1. That paragraph that has made me feel like I need a drink of water is just what's in the diagram. All they've told you is, oh, by the way, these lines, they're strings. That's it. That's the only thing they've said. And that. It's the only important thing in the whole question there. So we want to find out the tension in the string AC and the tension in the string BC. But before we do that, let's read the orange box. The particle can't move along the string. Like in the previous question, it was a bead, wasn't it? So it could move and it was one piece of string. So we have two separate strings, and if they're separate strings, they're going to have separate tensions. So you introduce suitable variables for the tensions of each. T1 and T2, they are not going to be the same tension in these strings.
How did you know that
How did I know that?
you can't move along the string?
Because it says that the particle is attached at C to the ends of two light strings.
There's two separate.
It says it's definitely two separate strings and it's in equilibrium. So one of these is going to be higher tension. One of these is kind of like a tighter and more taut kind of string. It's not actually necessarily tighter, but it will. That's how it would feel if you were to like touch the strings. One would feel like it had more tension in it. So we're going to draw this diagram. We could either draw on top of this one. Why don't we draw on top of this one? So we've got this particle here, and it's got a weight of 8. Not 8g. It doesn't say a mass of 8. It says a weight of 8. If it said mass, you would have to change it to 8g. And then we've got the tensions. I'm going to call this tension here tension 1, and I'm going to call this tension here tension 2. I'm going to split my forces like this, and like this, and like this, and like this. Muhi, what is this angle down here?
That angle is 35 degrees.
It's 35 degrees. So what would the force running along the side here be?
It's so T1 cos 35.
Oh, did you do it with A on yours? Okay, sorry. And so then the other one is obviously T1 sine 35. Running along this direction, which we've already got there, so I don't need the arrow. This angle is 25, so similarly, T2 cos 25, T2 sine 25.
Would T1 cos 35 equal to T2 cos 25?
Good. I'm actually still going to do my extra diagram, but what you've said is completely true. I'm going to just do my extra diagram where I have T2 cos 25, T1 cos 35. Very easy to make mistakes with these numbers here. And going up, T1 sine 35, T2 sine 25, and going down 8. Let's make sure we get all of the marks for this question. All we can do, really, is resolve left and right. That's the only option. We can either do up and down or left and right. It doesn't really matter. So we get T1 cos 35 equals T2 cos 25. Why don't...
Isn't that two different variables?
They are two different variables, yeah. So why don't we make one of the things the subject? Let's say T1 is equal to T2 cos 25 divided by cos 35. I've just made it the subject because I know I'm probably going to need to substitute it in the next part. And then we're going to resolve up and down.
T1 sine 35.
So we get T1 sine 35 plus
T sine 25.
so many numbers that look similar here equals 8.
Just sub in.
And we know that T1 is this thing here. So I can sub that in there and we get T2 cos 25 over cos 35 times sine 35 plus T2 sine 25 equals 8. What should we do on the left-hand side?
Take that T2 from both of them.
Yeah, if we want, I guess we could actually just start working these things out as numbers now, if you want to, or you could factorize. I think there's quite a lot of typing going on here. I'm probably going to make them numbers just because it's mechanics and I'm okay to do that. So cos 25 divided by cos 35 times... I just want to see what these are as numbers. It's going to be easier to solve this equation if you just see them as numbers. If you want to, you could factorize it, but I just think it's going to take more time to write it all out. It's easier to make a mistake. So I've just worked this thing out, and it is 0.63460 T2 plus sine 25.
Wait, so why did the T1 disappear with the
I replaced T1
Oh,
with
that.
this thing,
Okay.
okay? And then sine 25 is 0.4226, blah, 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 T2, which is equal to 8. So then you can add these two bits together, and you should get
What the hell?
I've got 1.057 T2 equals 8. So T2 equals 8 divided by that. And that's 7.567 or 7 point, let's just do two significant figures. Two significant figures.
Which one did you call T2?
I called the one going to the right T2.
It's the sine.
Oh,
The difference is, you know, in the fourth line where you multiplied it,
Yeah,
you know how you would, for example, add them together resulting force, what would multiplying them do?
He replaced T1 with.
yeah, I've replaced T1 with this because of this thing I had up here. So I started doing simultaneous equations. So then I get that T2 is this. Let's finish off the question though. Let's come back up. T1 is equal to T2 cos 25 divided by cos 35. So keeping that in my calculator, that's 7.56. Timesing it by cos 25 and dividing it by cos 35.
Cos 25 and cos 25.
And we should get 8.37. Let's just keep it safe. Let's just do it to two significant figures. And we get 8.4 newtons. They sound like quite reasonable sizes. They're not like, oh my God, it's like millions and millions. And they're also not super, super tiny as well.
So I won't use the simultaneous equation solver.
No, you can use the simultaneous equation solver as well.
And if I just say that, just say the answers. they'll
Yeah,
get it.
it's absolutely fine.
That's fine.
At which stage did you use the simultaneous equations?
When
Did you
had
just...
the resolving, so I've got the 8 is equal to T1. Oh, no.
I'll tell you what, I'm gonna speak to the whole class about this in a second because it's a good technique to do.
I mean, if I've got it, I might as well use it.
Oh. So,
In terms of where the marks come from, you get 2 marks here, 3 marks here, a mark for that, a mark for that. How many is that? 1, 2, 3, 4, 5, 6, 7. You get 1 mark for actually solving the simultaneous equations.
so you get.
So mechanics is not about this complicated bit here. Mechanics is all about the first sentences being absolutely perfect. Okay? Yes?
You know where you subbed in T1, I guess.
Yeah.
Oh, yeah.
What I did, instead of just plugging it in, I kept going. I ended up with one of the
you could do that.
sine A plus B.
Yeah. You could do that, but it's just not necessary for mechanics. It doesn't need an exact answer, so it's good. Okay. One thing I just wanted to say that Rayhan told me about the simultaneous equation solver on your calculator.
They can do that as well.
So he might have, I think what you did, Rehan, did you take this first equation and you changed it to T1 cos 35,
Take away T2.
take away T2 cos 25 equals 0.
Wait, my one I did the other way.
But it doesn't matter, yeah. So then he would have put the variables cos 35 minus cos 25 equals 0. And then for this second one, he would have said sine 35, sine 25, and 8. He then would have just done the simultaneous equation solver on the calculator, pressed equals, and it would have come straight down to this and this. And that's completely fine to do in this kind of thing. Yeah.
But here you achieved only 7 marks, so it's hard.
I feel like I make mistakes.
No, you would get full marks for you would get full marks for
The
doing
thing
that.
is, the more you write, the more likely you are.
So you have got, I'll leave that one on, but you've got to do this question for me here. You're going to do the parachuters question, and then you're going to do some practice that's for homework, okay? So I shall leave it on this, but you've got to do the next question on the next page, okay?
And majority